Alright, so this is your problem, and let's go ahead and draw this out again. So we have A, B, C. We don't have the angle A, but we have the side length A, so that's over here. We get side length 1 for C, and then we've got 25 degrees. So we've got the side, the angle over here. So remember, if it was, just to kind of remind you, if it was here, we had a length here and here and here, this would be side, angle, side. And if you remember back to geometry, this is actually would be a side and then another angle. And if you guys remember correctly, that was never a thing. So that might be a way to help you remember this. However, we're going to assume that there's going to be two. And how do I know this? Because what's going to happen is I have two side lengths and one angle, so I'll have to find an angle first. Okay, so I've got sine. Look at this, we've got C and C, so sine C over C. We're finding an A, so sine A over A. Sine of 25 degrees over 1 equals sine of 2. Oops, that's a lie. Sine of A over 2. So, ding ding ding. Got to find an angle first. I'm using the law of sines. That's a problem. Okay. So, if I rearrange this, I'm going to have 1 sine A equals 2 sine of 25, and you do a cross multiplication. And then A is going to be the inverse sine. When you do that inverse sine first, you always want to be thinking about are there two. Hopefully when you did this, you got 57.1 decimal place because it is an angle. This is a bit of a pain. 7, so 57.7. Now, I'm going to keep going on, but I want to be thinking about this for my potential second triangle over here. Okay, I'll come back to that. So let's just keep finishing this one and we'll come back to this. Okay, so I know C, I've got A, I can get B. A plus B plus C equals 180. So A is 57.7, B we don't know, and C is 25. And when I subtract, I get 97.3 degrees. So let's see, I have A, B, and C. A was 57.7 degrees, C was 25 degrees, and then I've got 97.3. Have A, which is 2, C, which is 1, we just have to find B, then we're almost done. So use what you can of the original, so sine C over C equals sine B over B. So sine of 25 degrees over 1 equals sine of 97.3 over my unknown B, so cross multiply. The 1 disappears, all gets absorbed into the sine 97.3. Do this on your calculator. When I do this one on my calculator, it does not like if I do not close the parenthesis. It tells me there's a problem, so you better be careful with that. Okay, so that's the first triangle. So, oops, that's not degree, it's the side end. Let's check to see if there is a second triangle. Alright, so I circled this, or boxes, because this is what I want to use. So back here, see if there's a second one. I'm going to do A plus B, well actually I'll come back to that in a second. I take the 57.7 and I subtract it from 180. So this could give me potentially my A sub 1. So if I do 180, subtract 57.7, I get 122.3. This always can be confusing. So then I go A plus B plus C. The reason it would be 2 is if this adds up and there's still enough room under 180. What? Okay, so A was 122.3. We had C and 25, and then B. So since I subtracted those over and I got a positive answer, this tells me that I have a second triangle. And my second triangle, let's squeeze this in here, it gives me an angle A, B, C. C is 25, they both have 25. This one is 122.3. and the other one is 32.7, and we usually say sub 2, sub 2, sub 2 because it's a second triangle. If you don't, that's fine, just make sure you have your two lots separated out. Okay, So I have, I need to find A, B, and C. Let's see what I have. I have A, which is 2, and C, which is 1. So at this point I just have to find B. So again, use what they give you, sine C over C. I'm trying to find B, so sine B over B. Sine of 25 over 1 equals sine of 32.7 over my unknown. So B is 37, oops, I'm sorry, sine 32.7 over sine of 25. And that gives me an answer of 1.28. So longest angle, or biggest angle, longest side length, smallest angle, smallest side length, middle, middle. And that's my 2 triangles. So this is not all this part here is not super hard. It's when I transition from here to up to here, that's when it gets a bit weird.